Hello, Daryl here. The channel is Programming in Any Language. The supporting website is programminginanylanguage.com or black-duck.com. They both take the same place, and it's a place where you find the videos and PDFs of the code. The video is polymorphism. Polymorphism refers to an object's ability to take on different forms. Basically, it allows you to have methods with the same name in a base class as well as their derived classes. You also have the ability to override the properties and methods of the base class. This video explains all this with two different examples. In the first example, we create an animal class that has a make sound method that only works for some animals. A derived class, like dog and cat, overrides the make sound method with sounds more in line with what a dog and a cat actually sound like. A second example uses a rectangle for the base class. Its properties are length, width, and area. Works great for rectangles, but in order to go three-dimensional, we add height as a property of the derived box class and override the area property. This is all pretty straightforward, actually. Let's take a look. When it comes to object-oriented programming, there's a lot of big words they use to describe the different aspects of object-oriented programming. One of those big words is polymorphism, and that's what this video is all about, polymorphism. Polymorphism refers to an object's ability to take on different forms. It allows derived classes to have methods with the same names as methods in their base classes. It allows a program to call the correct method depending on the type of object that is used to call it. When a derived class inherits from a base class, it gains all the methods, fields, properties, and events of the base class. To change the data and behaviors of the base class, you have an option to override a virtual base member. Override and virtual are keywords we're going to be learning about here. Two essential ingredients of polymorphic behavior: the ability to define a method in a base class and then define a method with the same name in a derived class. Also, the ability to call the correct version of an overridden method depending upon the type of object it is used to call it. The derived class overrides a base class method. If a derived class object is used to call an overridden method, then the derived class's version is the one that executes. And if a base class object is used to call an overridden method, then the base class's version is the one that executes. The keyword virtual is used to declare that a derived class is allowed to override a method in a base class. Right here you can see we have the class animal, and we defined a field called species. And there's a constructor there that's allowing us to create species, and the species are getting a set because the species is a property. We then have a method, public virtual void make sound. We have a message box show that says grr in it, G-R-R. Now, not all animals go grr, and that's the reason we have virtual in there, because if we want to use this animal class to define any other kind of class, we want to be able to override that method there. So in this particular case, though, we have a button called animal, you can see on the bottom down there, and we're creating a brand new animal and giving it regular animal as the species type. We're passing that to the creation as we create the instance of the class. And our message box show uses the $sign to tell it it's got code in there. The species is animal species. So whatever is in the species is going to be displayed in the message box, and that will be regular animal. Then it's going to make a sound. My animal makes sound, and another message box will pop up showing grr. Let's demonstrate that. What I have here is a quick animal demo program. We're going to use the first button, animal, here. We'll use the other ones as we go throughout this thing. But we're going to take a look at that animal class that we're actually creating here. And all these things are just to be consistent with what I do when I show these things. I've got button animal here. I've got button dog, button cat, button dog 2, button cat 2, and an exit button down here. And that's it. There's no code written for this thing at all. What I'm going to do first, I'm going to create the animal class. So we'll jump in here and do an add. That class we'll call animal. And in that class, we will create the pieces we need. Basically, we're going to create the species string of field. We're going to then public animal string species. The constructor is going to be in there, and we're going to have a get and set for the properties, and we're going to make sound grr. That's it. So we have this animal demo sitting right in here. Now what we want to do is we want to take this particular form we've got here, and we want to be able to create the animal button that's going to apply this. So we'll jump in here and click on this. In the button animal, we will create a new my animal. It'll be a new animal, and we'll pass it regular animal to the species piece that we're going to be picking up. Then we're going to go ahead and we're going to have a message box that the species is animal species and called make sound. And that's all we need to do. And if we actually run this thing, we'll do a file save all on this thing and run it. So we come up with our animal demo here. We have the animal button right here. And if we click on this thing, it's going to create that new animal instance. And it's going to pass regular animal to the class. And then it's going to bring and pull the my animal species from the class, so from the instance, to show what we actually have in here, which will be regular animal. And then it'll jump to the my animal make sound method. So if we click on this once, we can see that the species is regular animal. So that's coming up right now. The regular is popping in there. We click OK on this, the make sound pops up, and we get grr to show up there. That's all there is to it. That's all we can do with this particular thing. So seeing that, how do we make any changes to this particular thing? Well, if we want to use the override, the keyword override declares that this method overrides a method in the base class. So we can create a new class called dog based on the animal class. In this case, we have a string name, we have base dog in here. And we have a get and set for the property, the name property. And we would override and make sound in the message box and go woof woof. Now we can do down here, when we actually create a button for this dog, we create the new dog Fido, passing Fido to the name property. The species is my dog species. The message box shows the animal's name is my dog name, and make sound is going to pop up here. So you can see in all cases, we are creating my dog based on the dog class, the derived class, and then using that to do all the things it's going to actually do. So let's take a look at that in action. What we need to do first is create the dog class. So we will go ahead and add a class. Call it dog. And inside the dog class, we'll create all of our features that we're going to be having in here, base dog and all this. What we're missing right now is dog is based on something. So we need to put a colon in here and say animal. And that'll take care of our errors. So now we have a dog class sitting here with a name in the constructor and a get and set property and a make sound and woof woof. So we're going to override the make sound command of the animal class, although we're going to use the species of the animal class. So what do we got here? Let's take a look and see how this thing actually runs. Well, we got to first of all create the form piece. So we're going to go in here and do our dog area here and create a button that's going to actually work for this thing. So what we're doing is we're going to create dog, my dog equals new dog Fido. So we're going to pass a name property to this particular thing as we create the instance of the dog class. Then we're going to look at the species, my dog species, and we're looking at the my dog name and the make sound. So all three of these things are going to be taking place as we go through this thing. So let's go back to our form. I want to actually have this, let's let it come up where it does come up. I want to go back to this form code so we can look at the form code and run this. File save all. Start it up. And there's our program again. This time we're going to hit the dog button. And so as we do this, we're going to create my dog with a new Fido class. So go in there and right away, the species is dog. This is coming up. So it's actually showing us that my dog species is this. If we click on it again, the animal's name is Fido. So that's coming out great. And then we'll go to make sound and woof woof pops up. So this overrides the make sound in the original class. That's what happens now when we actually create a derived class called dog. So you can see how that worked with the override button going in there. We can replicate what we just did by adding a cat class. So I'm going to go here and I'm going to add another class here. And do the same thing we did with the dog class. We're going to have the same errors, of course. So we'll have to say the cat colon animal. So the cat class is based on the animal class. Again, retrieving all the features of the animal class, but it has some overrides in here. Again, we have a name here, base cat. And we have a get and set property, we have make sound, we have meow as the make sound override that we're going to be doing here. The next thing we have to do is go into the form and create the code for the cat button. We'll pop in here and do that. And that's nothing more than the same thing we did with the dog button. We basically have a new cat called Kitty. We'll pass Kitty to it. The species is going to be my cat species, so it should bring back what it is. Message box I show the animal's name is my cat. And we're going to bring up the name, and we're going to have the make sound in here, going like that. So now we can do our file save and do our run. I'm going to bring this off to the side so we can kind of watch this code down here. If we do our cat, the species is cat. We do OK on this. The name of the cat is Kitty, so it's bringing in that name just nicely. And the method is, or the make sound method brings up meow. Dog thing still works. Species is dog. Animal's name is Fido, and woof woof. And of course our animal class still works too. The species is regular animal, grr comes up, and that's it. There is a relationship between the base class and the derived class. An object of the dog class is not just a dog object, it's also an animal object. Because of this relationship, we can use the animal class variable to reference a dog object. How do we do that? If you take a look here, we've got the class animal, we've got the dog class based on animal sitting right in here. Our species is sitting over here. We have the dog's name over here. Our gets and set are fine. We have a virtual make sound. We have an override here. We're going to create a button dog 2 here. And we're going to have animal, my animal equals new dog. So we're going to create a my animal instance based on the new dog Fido. So instead of having my dog in here, we're going to have my animal. And we're using animal here as the class we're going to be actually basing it on. The message box show the species, my animal species, and it makes sound. So what's going to happen when we actually do something like this? Let's take a look. We don't need to do anything to the dog class or the cat class. We're going to use them as is. What we are going to do is we're going to go out to this form here and go into our dog 2 button. And prior to doing the dog 2, I'm just going to put a comment in here. And because of the is a relationship between the base class and a derived class, an object of the dog class is not just a dog object, it's also an animal object. A dog is an animal. Because of this relationship, we can use an animal class variable to reference the dog objects. So we've got our button dog 2 here. I'm going to go ahead and pop in the code that we were going to do to create this thing. We'll see what we're looking at here. You can see I'm going to bring this up just a hair. We can see the button dog up here. We can see the button dog down here. Up here we did dog, my dog equals new dog, Fido. Here we got animal, my animal, new dog equals Fido. And we got a message box. The species is my animal species. We're going to be looking at what the species comes up with in the my animal variable. Our difference, we're looking at the animal instead of the dog piece. And we're going to have my animal make sound pop in there. So let's go ahead and save this guy. And run it. And this time we'll hit dog 2. The species is dog. So instead of saying regular animal, even though we're using the animal class, it's coming up and finding that the dog piece has a species called dog. So that's popping in just nicely in there. And the make sound is woof woof. That's happening just fine. And that's all there is to it. We can go ahead and do the same thing with cat. I'll jump in here. We use the same cat class, but in this case, I'll jump over to the design, jump into cat 2, and we'll pop in code for him. New cat Kitty, species, make sound. We'll file save. And let's go one more step and actually put an exit button in here. Close that form up nicely and run it. Here's our animal demo. Draw our cat. Species is cat. Meow. Dog 2. Species is dog, woof woof. Dog 1. Species is dog, name is Fido, woof woof. So we're getting that name popping in here because we're actually defining it in there. We don't define that in here because we're using the animal. And that's what we've got for this thing. Exit works as well. So you can see that difference between the animal and the dog animal here and how we can actually make that work. Now, properties in a base class can also be overridden. In the base class, you write the virtual keyword in the property declaration, as you can see down here. We have a get length here. The rectangle class declares length and width properties, as you can see, with a virtual read-only area property. So this is also a property. We've got length, width, and area being a property. The virtual area property is based on the length and the width. The area property returns the area of the rectangle. We can create a box class with a length, width, and height based on the rectangle class. We can add the height property to the derived box class. We would then override the area property to account for the area of the box. So right here we've got a box based on a rectangle, and we're going to add the height property to it, getting set, and then we override the area property by returning base area times height. So in other words, the base area, which is length and width in the original class, we have that as the area of the rectangle, and by multiplying it by the height, we get the area of the entire box, the cube, basically, or the solid. What we have here is we have a form that's going to have area in it, length, width, and height are going to be taken in by the user. And we have an area for 2 dimensions and an area for 3 dimensions. So basically, this is going to be our length and width. This is going to be our length, width, and height. We have a clear button and an exit button as well. We have these things named. This one happens to be txt length, txt width, txt height. We've got a button called button area 2 dim, button area 3 dim for 3 dimensions. We have a label area 2 dim and a label area 3 dim, so we can display the answer when we actually make this all happen. We have a clear button, button clear, button exit. Now, what we need to do is we need a rectangle class. So we're going to go out here and we're going to create the rectangle class. We'll call it rectangle. What we're going to do with that rectangle is pop in the pieces we need. And we have our length and width property sitting in here. And we have the area property sitting here too, which is a virtual property. And we're going to return length times width. So it'll actually take these two with this. So the virtual property of area will be a length times width. But we're allowed to override this by putting the virtual in there. So our rectangle is sitting here like this. We're going to write some code for just creating an area. We're going to go ahead and bring in length and width. We're going to set up 2 variables called int length, int width, setting them at 0. We're then going to use a try parse to make sure that the data coming in from our user is going to be a numeric integer coming through this thing. So in both cases, we'll see invalid width or invalid length. So our meat of the project right here is going to be right here. If we end up with the correct width and the correct length, or a legitimate length and width, we'll be able to go ahead and create a image of the rectangle called my rectangle. And we'll pass it int width to my rectangle width. That's the set property. And int length, my rectangle length, again, the set property. And then we're going to ask for my rectangle area, which is the area property. And it's already done the math in there by doing the multiplication of length and width. So we'll be able to actually see it pop in there. That's all we need to do for this thing. We'll do a file save on this, and we'll run it. If we pop in 5, and then down here a 4, we should have a length and width times 20. If we do go ahead and create this thing, that's exactly what we get. We get 20. Length times width is equal to 20. So it does a nice job of fixing this up for us. I don't have the clear button done or the exit button done here, but you can see that's what we've actually got. So that's all it takes. So what we've done there is we've taken the length and the width, brought them into our triparse to see if they're valid or not. And once they are valid, we come out with int length, int width sitting with data in them. And we end up passing it. We create our new rectangle. And as you can see, our width uses the set, the length uses the set, and then our rectangle uses the get return length. So we bring that out, and that actually gives us our data coming in here. So that's all we needed to make this thing actually work. Now, let's take a look at the box. In order to use the box area, we need to create a box class. So we'll do that. Do an add on this, and we've got it set to go. Now we can bring in our data, our code, and we have our height and our override of the area, which will return base area times the height. We have to create this box based on rectangle to get rid of the errors. And once we do that, we're in good shape here. So we're going to be creating a get and set property for the height. So we'll bring that in from our text boxes. Then we're going to use the override of the property area. And instead of returning the area, we're going to return the base area times the height. We're going to actually multiply it again by something else, by another thing. So we have length and width here times the height to make it actually work. So what does this thing look like? We jump through our form and we actually code this button right here. It's going to be very similar to the button we did before. In this case, we add height to our variables. So we've got three different variables sitting out here: int height, int width, length, width, and height. Then we do an int triparse on all these things. We have to add the height to this thing as well. So our typical verification of data is going to be straightforward. We have our arrow-shaped thing here, where we've got our check of these particular pieces, and then our invalid height, invalid width, invalid length coming out in message boxes down here. So our code that we're actually using is going to be sitting right in here. And what do? We create box, new box, my box equals new box. We're creating a box object, and it's based on the rectangle in many cases. Then we're going to bring in the width, height, and length. So we're bringing in the properties. In width, in height, and length are coming in from our variables of the data that came in from our text boxes. And then we're simply going to go ahead and produce the area by simply saying my box area, what is it? And we should have a correct answer coming in there. That's all we need to do. We're going to save all. I'm going to go ahead and very quickly create the clear button. Make this thing nice. We'll clear our text box and our labels and then set our focus at the length. And we'll also create a exit button, which will close the form. So I'll save all now. Let's go ahead and take a look at this. Here's our area. We'll put in 4, 5. We'll put in 3 here for our height here. So we can still do an area dimension here of 20. That's going to pop up fine. It's going to grab our 4 and 5. But our area 3 is going to override that, and we're going to get 60 on this thing because it's going to take the 20 and multiply times 3 to get 60 for the area of the container, the box that we've actually created, and make that thing work. So that's all there is to do it. So it does work that way and comes up and grabs the stuff we need. We can clear this off. We can easily put something else in here like 10, 15, and let's say a 5 down here and do our calculations here, and we get it working just fine as we use different data to go in here. What's happening? What's happening is our 5, 4, and 3 are being checked in the triparses. They're coming in through there. And when they are successful, they will go out to int length, int width, and int height, which are defined as 0 right here, but we're actually putting something in there. We don't have to worry about our invalids here. We end up creating our box, new box, and we're going to take our box width, height, and length and pop them into our instance. Then we come out with, and as you can see, they're going in. The width and the height go right into the rectangle or base class. The width and the length go into the base class. The height goes directly to this property in the box, or getting set here. And then we return our overridden area which is base area, which is length and width multiplied together, multiply times height to give us the new area. And we end up displaying that in our label. And that's all there is to it. So that's how we can override a property. As we saw in the beginning, we saw how we could override a method. Now you can see how we can override a property when it comes to polymorphism, these classes. And that is polymorphism in a nutshell. I think the term polymorphism is the most confusing aspect of polymorphism. In effect, we're just taking a base class and overriding methods and properties to fit a new derived class. The next piece is abstraction. And then we'll need to create a few applications to make all this new knowledge fit in with our programming. Thanks for watching. Visit the website when you get a chance. And please subscribe to the channel. There's more stuff coming every week. Take care.